Good morning, everyone, and welcome to this presentation. As you can see on the screen, our topic is automating the recognition of microservices from business process analysis. First of all, I'd like to give you an overview of existing research relevant to our study. Next, I'll focus on our case study, and then we'll consider our identifying microservices methodology. Then, we'll go on to highlight our collaborative clustering technique, and finally, we'll evaluate the findings from our experiments before concluding the study and briefly raising some future research directions. There is broad consensus that traditional methods like components-based software engineering and commercial off-the-shelf fall short in addressing the challenges posed by monolithic systems. In contrast, microservices architecture offers a compelling alternative by enabling the division of systems into smaller, cohesive, loosely coupled, and most importantly, accurately identified units. This paper presents a novel approach to microservices discovery that stands out for two main reasons. First, it uses business processes as the foundational input. Second, we apply a clustering strategy to meticulously analyze dependencies in BP activities, concentrating on control, data, and functionality. Decomposing monolithic application into microservices is a challenging yet critical task in transitioning to a microservices architecture. Monolithic systems often struggle with scalability, maintainability, and agility. Decomposition involves segmenting these large systems into smaller, independently deployable services, each tailored to perform specific business functions. Approaches to decomposition range from manual to automated methods, including the use of algorithms that perform static and dynamic analysis to define logical service boundaries. Various methodologies have been proposed to automate this process. For instance, Jin et al. Details a method that clusters execution traces to extract microservices based on functionality. However, the effectiveness of such approaches can depend heavily on the quality of execution traces, which in turn relies on robust testing. In Gazin et al., the service clutter tool assesses function with a system to propose optimal service divisions based on data cohesion, service coherence, and communication costs. Meanwhile, Levkovitz et al. Suggests a transition strategy that utilizes dependency graphs to delineate microservices based on objects, interfaces, and database interactions. Moreover, Clock et al., on the other hand, introduces an automated approach to optimize microservice performance and scalability by analyzing architecture, workload, and functionalities, underscoring the significance of performance metrics in microservice architectures. Overall, the shift from monolithic to microservice architectures requires intricate planning and execution, with automated tools and methodologies playing a crucial role in simplifying this transition. Now, let's focus on Bicen, our case study. It's a bike-sharing scheme in Barcelona that encompasses over 400 bike anchor stations dispersed throughout the city while offering approximately 6,000 bikes available for renters by users for a fee. For our research purposes, we propose a top-level depiction of Bicen from a business process standpoint. This representation employs the standard business process model and notation, BPMN. For clarity, we identified various activities, several dependencies, distant logical operators, and diverse artifacts such as bike and user, along with their corresponding attributes. Additionally, the subsequent discussion in this presentation encompasses not only bike rental, but also other facets such as reporting and repairing bike defects and, if required, bike disposal. The displayed figure outlines an array of tasks such as A15, inspect bike at station, and A25, GPS update on bike. We've identified various interdependencies. Moreover, we've detailed different logical operators. The display table offers a detailed view of activities, artifacts, attributes, and associated operations. These elements are integral to understanding and refining the bike sharing operational model. These activities can read or write data, potentially creating, updating, or deleting the artifacts themselves. In our study, we refined the approach to identifying microservices by focusing on control and semantic dependencies within business processes. Our method quantifies these dependencies through metrics that assess activity cohesion and coupling. To evaluate execution dependency between two tasks, AI and AJ, we calculate the probability of AJ following AI based on their execution sequence and logical connectors. Furthermore, our approach explores semantic dependencies by associating activity names with specific segments of a domain and ontology. This strategy